Alright, here's question 3. So part 1 is that we just want to look at this program and see what it does. So I've got this in my Visual Studio Code here, and we'll debug and see what happens. Now I'm sure most of you are very smart cookies, so you can have a look at this and pretty quickly realize what you think might happen. But we're going to challenge a few assumptions maybe. Okay, so we have a conditional branch here, and I'm sure most of you can work out that nothing before this conditional branch in the program is going to set flags. This LSL won't set flags, and this mob won't set flags. So we should just not take this branch. Let's step again, and there we have it. We have actually taken the branch. Now I know this is somewhat confusing in that nothing before this branching statement should have set the flags, but here's the gotcha. If we look in our startup file, there's instructions in here which are setting the flag. Because remember, when we start up our board, it starts at the reset handler here, and then it goes down, and it'll do our loop copy data init, and loop copy data init has an add s in here that's going to set flags and do stuff, and then eventually it does all this stuff and actually branches to main. So I guess there's sort of two correct answers to this question. What will happen? If our startup file was clean and didn't set any flags before branching to main, then we would simply spin around in an infinite loop in label 1. The left shift would not set any flags, we would never take this branch, and then we would loop back to label 1. But unfortunately, our startup file might set flags, and in this case it has actually set the carry flag, which means that we've branched out to label 2 immediately. We sort of have what you could call undefined or non-deterministic behavior. Okay, so let's look at part 2 now, where we actually will make our program behave in a sensible way. So part 2, we simply make the LSLS set the flags. Now let's have a look at what it does. Okay, so I'll actually bring up the register view now, because it's not just going to do something silly and unexpected. Alright, so here's our register 0, and we have a whole bunch of Fs in the lower positions in the register, and we're going to shift them left. Now, because nothing has been shifted, because only zeros have been shifted off the left of our register, if we check the carry flag down here, it has been cleared by our LSLS, and we will not take the conditional branch. I'll just run through here a few more times. Alright, so I've clicked through our thing a whole bunch of times. Now I'm going to change our register's binary. So the leftmost bit over here is now actually a 1. So what's going to happen when we shift it left a little bit more? So we're going to shift left 2 bit positions, and we've pushed some 1s off a cliff. And the last one we pushed off a cliff has fallen into our carry flag, which has now been set to 1. So we'll take our conditional branch into our sort of, end of the program do nothing loop. So I guess the answer for part 2, yes, the program will behave differently. It will behave the way we expect it to, and it will shift this number to the left until it starts to push bits off into the trash bin. So yeah, I personally don't think this was a particularly great question, and that it's a little bit of a trick question or a gotcha, but generally, when a good rule of thumb in assembly is that when things don't work the way that you expect them to, challenge your assumptions about things and you might find an answer. Thank you.